We can get a lot of information about a function just by looking at its graph. Here's the graph of a function. We can tell it's a function. It passes the vertical line test. Any vertical line I draw passes through that graph one time and only one time. So there's the first thing we can tell is that, yes, this is a function. If I want to know the domain of this function, domain is the x values that it uses. So that's left to right. There's a definite leftmost point here. Domain is x values, so this is x equals -3. I'm going to put an open parenthesis here because of my open circle. That point, -3, isn't actually on the graph. Because of the open circle, that point is left out, but x equals -3, and the way we leave it out is by using the parentheses. So x values start at -3, and my graph is going to keep going. Notice we have the arrow on the end here that says the graph is going to keep going this direction forevermore. It's not going to change. So it's going to keep going to the right forever. If it keeps going to the right forever, my x values are going to go to the right forever, which means positive infinity. So left to right, x equals -3 to x equals as big as you want. The range, we're talking about y values. One of the few times we're going to use interval notation to represent y rather than x values. Bottom to top. So I'm going to look for the bottommost point on my graph. Here it is. The y value here is -5. So the bottom of my graph is at y equals -5. It does actually hit y equals -5, and I'm going to say that by using a bracket. It says -5 is an actual y value of this function. Again, with the arrow here, my graph is going to keep going. So it's going to keep going up forever. My y values are going to go up for as long as you like, forever, which is infinity. Infinity always gets parentheses. Next, we can look at the graph to see where is it increasing, where is it decreasing. Increasing, as we go from left to right, increasing is going up, generally speaking. So here, I'm going to notice, as I go left to right, my graph is going up. Starting at, well, this point isn't actually on the graph, but starting from, what is that? That's -3, 0, until my point up at the top here is 0, 5. But when we talk about where a function is increasing, we're going to talk about it using x values only. So yes, my function is increasing from -3, 0 until 0, 5, but I'm going to use only the x values of those points. And that completely describes where my function is increasing. So I'm going to say from -3, and again, because of that open circle, I'm going to use the parenthesis, and up to x equals 0. We increase again, so I'm going to do U for union. There's another interval coming. From this point down here, we're going to keep going up forever. So this point looks like x is 6, y is -5. These aren't semicolons. This is just my comma ended up too small. So, and again, I'm going to use only x values. So starting at x equals 6 and continuing forever, my function is increasing. This one, you can debate if you want to have a parenthesis or a bracket. I think our homework generally wants parentheses, so we'll use a parenthesis there, but some people like to put a bracket. I'm in the parentheses camp. So there's where our function is increasing. Where is it decreasing? Decreasing is as we go left to right, where the graph is going down, so that's in between here. Again, we're going to use x values only of those points. So starting at x equals 0 and continuing until x equals 6. And again, you can debate parentheses or brackets. I like parentheses. So I'm going to use those. And that's the only place where my function is decreasing. Local maximum is like the top of a hill. So here's a local maximum point. It's not the highest the function ever gets. It's going to get higher going out to the right here, but it's a local maximum. It's the highest hill around. So my local maximum, the location of a local maximum is its x value. Where does it happen? It happens at x equals 0. The local maximum value is a y value. So the local maximum value is the y value of that point, and that's 5. Local minimum, we do have one of those also. Here it is. Here's my local minimum. Again, the local minimum location is the x value. Where does it happen? It happens at x equals 6. The local minimum value is the y value of that point, and that's -5. Absolute maximum is the highest that the function gets ever over all of its domain. Because we have the arrow there, we're going to go up forever. It's never going to hit a maximum. The maximum is the highest it ever goes ever. It's going to keep going up forever. So there is no actual highest value where it goes that high and then stops, because it's going to keep going higher forever. So absolute maximum, we're going to say it doesn't have one. And you can write that, doesn't have one. Or I'm going to write does not exist. DNE for does not exist. There isn't one. This is a pretty standard mathematical abbreviation. So if you write DNE, I'm going to know what you mean. And generally, most math people will. An absolute minimum, it does have a bottommost point, and it happens at this local minimum. Also happens to be the absolute minimum. That's the lowest it goes ever. That's a local absolute minimum value, which is a y value. So that'll be y equals -5. That's the absolute minimum of this function. An x-intercept is a point where the graph crosses the x-axis. There's one right there. Intercepts are points. They have 2 coordinates. So the coordinates of this point, we're just going to say the coordinates of that point where the graph crosses the x-axis. X is 3, y is 0. This particular function has another one, another place where the graph crosses the x-axis, so we'll put that on the list also. Y is 0, x is, it's somewhere, that's 5, 6, 7, 8. So it's more than 8, less than 9. I'm not going to buy that that's 8, and I'm not going to buy that it's 9. It's somewhere in between. But make your best guess. It's like 8.5 or something like that. I'm not getting out the magnifying glass or anything. So x is about, I'm going to put 8.5. Y is 0. If you put 8.4 or 8.6 or 8 1/3 or whatever, it's between 8 and 9. Y-intercept then is the point where the graph crosses the y-axis, and conveniently, it's right there. We've already named it. My y-intercept is 0, 5. F of 9. What's f of 9? Well, our function, whoops, there, it disappeared for a minute. Our function is f of x. So 9 is an x value. This question is asking when x is 9, what's y? F of x corresponds to y. So when x is 9, there's x equals 9. What's y? So I'm going to find the y value on the graph when x is 9. Looks like right there. That's y equals 1. When x is 9, y is 1. This bottom one then is asking the opposite question. This says f of x equals, there, -3. So this is y equals -3. When y is -3, what's x is the question that we're asking here. So when y is -3, I'm going to look for x values on the graph when y is -3. Here's one. When x is -3, y is 7. I just said that backwards. When y is negative 3, x is 7. And there's another one right here. When y is negative 3, x is right there, which is, that's a little bit more than 4. So again, not being too picky, but definitely more than 4. So I'm going to call that like 4.2, something like that. And if you call it 4.3 or 4.1, again, I'm not getting out the magnifying glass. So all of this information we can find just by looking at the graph.